Okay, so let's have our example. So the example is again the determine the Maclaurin series expansion up to 6 terms of e raised to the x power and use the series of to evaluate e raised to 0.5, which must be correct up to at least 3 significant figures. And then of course tabulate the results in the given format. Okay, so let's have an Maclaurin series. So the Maclaurin series representation is f of x equals to summation of x raised to the n power over n factorial f n of 0 from n is equal to 0 all the way to infinity. Okay, to expand that one again, so this one is equal to x raised to the 0 power if n is equal to 0 over 0 factorial f of 0 plus x raised to the 1 over 1 factorial f prime of 0 plus x raised to the second power over 2 factorial second derivative of 0 plus x raised to the third power over 3 factorial, and then of course multiply by f to the third power of 0 plus and so on and so forth. Okay, so in our example, we have to determine, of course, the Maclaurin series expansion of e raised to the x power. So e raised to the x power is equal to x raised to 0 over 0 factorial. So therefore, we have f of 0 plus x prime over 1 factorial. So it means x prime multiplied by f prime of 0 plus x raised to the second power over 2 factorial f to the second derivative of 0 plus x cubed over 3 factorial f3 of 0. Since this is up to 6 terms, so therefore 1, 2, 3, 4 plus x raised to the 4th power over 4 factorial f4 of 0 plus finally x raised to the 5th power over 5 factorial f5 of 0. Okay, so let's try first to approximate the value of e raised to the x power. So again, let's try to approximate the value of e raised to the x power. So and what makes it really simple is when you take the derivative, and this is frankly one of the amazing thing about the number e, is that when you take the derivative of e to the x, so you will get, of course, e to the x also, right? So the derivative of e to the x dx is equal to e to the x also. So therefore, if it is e to the x, first derivative is f prime of x. This is also equal to the second derivative, and then this is also equal to the third derivative, and so on and so forth, right? So that kind of the first mind-blowing thing about the number e. So the derivative of e to the x is also equal to e to the x. Okay, so let's take it the Maclaurin representation of e to the x. So we have to find f of 0. So this one is f of 0. What is f of 0? F of 0 meaning e raised to the x. So we have to substitute, of course, x as 0. So therefore, e raised to 0 is equal to 1. Right? So therefore, if we have f prime of 0, so therefore, e raised to the 0 again is equal to 1. And then, of course, f2 of 0, e raised to 0 again is equal to 1. Okay? So it is going, of course, to be equal to any of the derivative evaluated at 0. So it means the value is always equal to 1 if you take e raised to 0. Okay? So let's evaluate the value of e to the x. So again, e to the x is equal to, what is f of 0? This one is equal to 1 plus x prime of x prime over 1 factorial multiplied by 1, still x prime, plus x raised to the second power over 2 factorial multiplied by 1, still, plus x raised to the third power over 3 factorial multiplied by 1, still, plus x raised to the fourth power over 4 factorial multiplied by f prime of 0. F prime of 0 is equal to 1. And then finally, plus x raised to the fifth power over 5 factorial multiplied by 1, which is x raised to the fifth over 5 factorial. So this is, of course, the Maclaurin representation of e raised to the x power. Okay, so let's complete the table. So for term number 1, basically, we have e raised to the x power is equal to 1. Right? So this is, of course, the first term. So basically, the result is equal to 1. Okay. How to get the epsilon of t? Epsilon of t is equal to 1 minus e raised to 0.5 over e raised to 0.5. Okay? So you have to get, of course, the absolute value, and then the result is equal to, I think, 39.3%. Okay? How about the epsilon of a? So since epsilon a, the formula is the current value minus the previous value all over the current value. So we don't have any previous value, so therefore we have to leave it blank. Okay, so that is our for term number 1. Okay, how about for term number 2? So for term number 2, e to the x is equal to 1 plus x, right? So since we have e raised to 0.5, so therefore x is equal to 0.5. So the result for second term is 1 plus 0.5. Why 0.5? Because e to the 0.5. So therefore x is equal to 0.5. So therefore the result is equal to 1.5. Okay? So for the epsilon of t, so we have to get that one. So therefore we have 1.5 minus e raised to 0.5 all over e raised to 0.5. Of course, using your calculator, the absolute value result is equal to 9.02. Okay? How about for epsilon of a? So epsilon of a, our current, is basically 1.5 minus, what is our previous? 1 all over current. So 1.5 minus 1, basically 0.5 over 1.5, resulting of 33.33%. Okay? So for number 3, okay, for term number 3, so again, e raised to the x is equal to 1 plus x squared over 2 factorial. So therefore, e raised to the x, so we have to substitute, of course, 0.5 as x. So therefore, we have 1 plus 0.5 plus 0.5 quantity squared all over 2 factorial. So the result is basically 1.625, using, of course, your calculator. So same procedure for the epsilon of A, rather epsilon of T. We have 1.625 minus e raised to 0.5 all over e raised to 0.5. This one is equal to 1.44. Okay? For epsilon of A, so we have current, which is 1.625, minus previous, which is 1.5, all over 1.625, which is our current, resulting of 7.69%. Okay? So how about for term number 4? Okay? For term number 4, basically, e raised to the x is equal to 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial. So again, you have to substitute again e raised to 0.5. So x is equal to 0.5. So as you can see, the third term from term number 3, which is 1.625, which is this one, plus 0.5 quantity to the third power all over 3 times 2 times 1 is equal to 6. So therefore, using of course your calculator, 1.645833. So same procedure for epsilon of t. Epsilon of t is equal to 1.645833 minus e raised to 0.5 all over e raised to 0.5. Epsilon of t is equal to 0.175, same as epsilon of a. Epsilon of a is equal to current minus previous, which is 1.645833 minus 1.625 all over current, which is 1.645833. The result is equal to 1.27.